Hello kids, this is Mrs. Butcher and this video is about graphs of quadratics in standard form. Alright, so this is new topic, quadratics. Quadratic is when you have a squared x, and in standard form our quadratic equation looks like y equals ax squared plus bx plus c, where a, b, and c are the coefficients. The parent function for the family of all quadratic functions is f of x equals x squared, where it doesn't have anything else, just x squared. And the graph of that is shown below. You guys have seen this before. It's a parabola. And the lowest or the highest, depending on the way it's opening, but the lowest or highest point on the parabola is called the vertex. The vertex of our parent function is always at 0, 0. And then we have the axis of symmetry, which is the line that divides the parabola in half. If you were to fold it in half, that line is your axis of symmetry. Now, when you're graphing a quadratic, that's something other than the parent function. If it's got an a in front of x squared, if the a is positive, then your parabola opens up. So just think positive a is a happy a. It's a smile, and the vertex is the minimum. If the a is a negative value, like negative x squared, then the parabola is going to open down. Negative a's are sad, they frown, and the vertex will be the maximum point, the maximum value. And this is very important for you. The axis of symmetry, which will also be the x-coordinate of your vertex, is always x equals negative b over 2a. Very, very important for you to memorize this one. So when you have standard form, you just take negative b over 2a, and you know where the middle of your parabola is. You know where the x-coordinate of your vertex is and your axis of symmetry. And this comes in handy when you're trying to plot a graph of a quadratic and it's written in standard form, because you can find this first and you can draw your axis of symmetry. This will be the x value of your vertex, and so then you can just plug this x value into whatever the function is and then get the y value of your vertex. All I'm saying here is negative b over 2a gives you the x value, and then f of negative b over 2a, you just plug that x into the function, you'll get the y value of your vertex. Another important thing to note is when you have your quadratic in standard form, c is going to be your y-intercept, because if I were to plug in a 0 for x, all that would be left would be c, and so you have a point at 0, c. You always do in standard form. And so that gives you 2 points to start with to plot your parabola. All right, this next thing that I want to give you is the equation for the area between a parabola and a horizontal line. And that area is 2/3 base times height. So if we do a quick example of this, suppose we had y equals negative x squared. And suppose we had y equals negative 4. I'm just going to sketch this real quick. Y equals negative x squared is a reflection of our parent function parabola, y equals x squared. Y equals negative 4 would be a horizontal line down here, where that's negative 4. So what we want to do is figure out these two x values so that we can know our length of our base. Okay? So what we do is we just plug in negative 4 equals negative x squared. 4 equals x squared. X equals plus or minus 2. Plus or minus 2. So we now know the base is 4 units long. And the height, this value right here, we know that's 4 units, because we know the y value is negative 4. So if I want to find the area of this whole little beehive thing here, then I would just say the area is 2/3 times 4 times 4. And when you do that, you get 32/3 units, square units. So that's how you would find the area between a parabola and a horizontal line. All right, so now we're going to do some word problems. Okay, here's a tricky one, and I'm going to tell you right now, you're going to see one like this in the homework, and then you're all going to ask me how to do it, and then you're going to see this again on the quiz or test, and you're going to say, I have no idea how to do it, so pay attention. All right, a witching supply store sells 150 dead bats per week at $20 each. The owner estimates that for every $1 decrease in price, 25 more dead bats would be sold each week. How can the owner maximize weekly revenue? All right, so first you have to know revenue is not the same thing as profit. Profit is what you get to keep. Revenue is all the money you bring in. Cost is all the money that you have to pay out, and then profit is your revenue minus your cost. So we just want to know how much money are they going to put in the cash register at the end of each week. All right, so how do we calculate revenue? Revenue is equal to the price of the bats times the number of bats sold. And that's what we're trying to maximize, so we're going to let that be our y value. So what is the x then? X is going to be the number of times that you decrease the price, because we want to know how much do we decrease the price, so we're going to let that be the number of times that the price is dropped by $1. All right, so our price then is equal to $20 each minus 1x, right? If he drops the price by $1 one time, then it's $19. If he drops the price by $1 5 times, then he's dropped it by $5, and 20 minus 1 times 5 is 20 minus 5 is 15, and so on. So that represents our price. All right, so now our function, we'll say r of x, the revenue, is equal to, how do you find the revenue? The bat price, which is 20 minus 1x, or 20 minus x, times the number of bats sold. And the number of bats sold is, well, he says there's 150 sold each week. And every time we drop the price, so plus 25 more, 25x, gets sold. So this is your quadratic equation, with x representing the number of times he drops the price. And that's what we want to figure out. How many times should he drop the price in order to maximize revenue? Since this is going to make a quadratic, it will have a maximum point. All right, so let's FOIL this out. 20 times 150 is going to be 3,000. 20 times 25x would be plus 500x. Negative x times 150 minus 150x. And negative x times 25x would be negative 25x squared. So to put this in standard form, a is negative 25x squared. These two go together. 500 minus 150 is 350, so plus 350x. And then our constant is plus 3,000. So this is a sad parabola. It opens down, which means it has a maximum. So that value right there is the maximum revenue. We just need to graph this. Well, actually, we're not going to use our calculator. We're going to do this by hand because we just learned that our vertex is at negative b over 2a for the x part, right? So negative b, negative 350, over 2 times negative 25 gives us 7. That's x. That means 7. He's got to drop the price 7 times. All right, so the question was, how can they maximize weekly revenue? They can lower the price by $7, or 7 times $1, so lower the price by $7. And the question just said, how can they maximize weekly revenue? So that's how. If the question said, what is that maximum weekly revenue? All we would need to do is take this 7, plug it into this equation for x, and solve for y. And to save you some time, I'll just tell you that that would give you a y value of 4,225. So that would be what the maximum weekly revenue would be. So the owner should lower the price by $7 for a maximum weekly revenue of $4,225. So you see how this is useful in business applications, because they want to figure out what's the, that's how Walmart prices their clothes, is they figure out, they have all these algorithms, and they figure out how much they think they're going to sell, and if they lower it to this much, they'll sell this much more, and all of that. So there you go. All right, yeah, you thought I was done. Haha, no, we have another word problem to do. You don't have to write down this whole word problem, but just write down the steps that you need to take in your notes. This is the car insurance problem. It says, suppose you are an actuary for F. Bender's Insurance Agency. Your company plans to offer a senior citizen's accident policy, and you must predict the likelihood of an accident as a function of the driver's age. From previous accident records, you find the following information. 20 years accidents per 100 million kilometers driven, 440. 30 years old, the accidents per 100 million kilometers driven would be 280. And for 40 years old, there would be 200 accidents per 100 million kilometers driven. So we're going to take these numbers, and we're going to come up with the quadratic that models it. And so when we have a group of x's and a group of y's, there are ways to do this by hand, but we're just going to do this in the calculator today. We already talked about how to find the line between several points. Now we're going to figure out the quadratic. And all you have to do is hit Stat Edit, same as we've done before, and put the x's in list 1, and put the y's in list 2. And then we're going to hit Stat, and then Calc. And then instead of linreg, because we don't want the linear regression, we want quadreg, because we want the quadratic regression. Quadreg. And you know this is quadratic because you've been told that it is. I'll teach you later how to figure it out if you didn't know. But right now I'm just telling you this is going to be quadratic, so use the quadreg. All right, so it says... A, write the particular equation expressing accidents per 100 million kilometers in terms of age. So you're going to do stat calc quadreg. It's going to give you y equals ax squared plus bx plus c, and you fill it all in. You should get y equals 0.4x squared minus 36x plus 1,000. So we're just copying it out of the calculator. B says, how many accidents per 100 million kilometers would you expect for an 80-year-old driver? So what we can do now is we can just plug 80 in for x. And when we do that, we come up with 680 accidents per 100 million kilometers driven. All right, part C, if you look back at what it said, based on your model, who is safer, a 16-year-old driver or a 70-year-old driver? So when you look at that parabola, which looks like this, by the way, all you have to do is go to y equals in your calculator and graph it, and then you have to kind of figure out a window. I went with my window of 0 to 100 because the x is the age of people, and then I went with 0 to 1,000 because I just got 680, so I knew it needed to be a little bit more than that. All right, so we want to know which is safer, 16-year-old or a 70-year-old. And in your calculator, you can actually hit second calc value, and it'll give you that x value, that y value immediately. So if I were to plug in a 16, or if I were to do second calc value, 16-year-olds have 526.4 accidents per 100 million kilometers driven, and I can do 70-year-olds, and 70-year-olds have 440 accidents. See, 70 is going to be over here somewhere, 16 is going to be over here somewhere. So who has more accidents? The question is, who has less accidents? Less accidents would be the 70-year-olds. But not by much, huh? All right, D says, what age driver appears to be the safest? Well, the safest driver is down here because that's the least number of accidents. So we need to find that. You can do your negative b over 2a. So 36 over 2 times 0.4. And you're going to get 45. So those 45-year-olds, like your parents, they're the safest drivers out there. And the last part, part E, says your company decides to insure licensed drivers up to the age where the accident rate reaches 830 per million kilometers. What then is the domain of this quadratic function? So we got to figure out where the accident rate is 830, And what you're going to do is you're just going to go to y equals and graph. Y equals 830. And then you can figure this out and this out by doing second calc intersect. So graph y equals 830, and then just find where it crosses, and you're going to get two y values. One of them, two x values. One of them is x equals 5, and the other one is x equals 85. So 5-year-olds and 85-year-olds would have that many accidents. The question is, what is the domain? Well, we're not going to actually start it at 5 because 5-year-olds don't drive. So we're going to start this at 16. That's our domain is 16 to 85. They will insure all people between the ages of 16 and 85. Once they're older than 85, their risk of having an accident gets to be too high, and they don't want to have insurance for them anymore. All right, so that's how insurance companies figure out their rules. And I'm done, so you guys have a good evening. Good night.